Driving down the road going 20 meters per second. When the driver sees a stop sign up ahead, the driver hits the brakes, stopping the car in 50 minutes. What is the acceleration of the car while it's slowing down? Well, we have to make sure that we do our first step, which is drawing the picture, which is already done. Here's the car. We marked that the velocity of the car is initially going to the right, but since it's slowing down, the acceleration has to be the other way. And we wrote down all 5 of our variables. Now the next step that we have to do is filling those variables in. So we're going to go back through the problem and see what numbers we have to plug in. A car is driving down the road going 20 meters per second. That's how fast it's going at the beginning of the problem. So that's going to be an initial velocity. So we'll put it there. Driver sees a stop sign up ahead, then the driver hits the brake, stopping the car in 50 meters. So 50 meters is obviously a distance or a displacement, so I'll put it there. And there was actually another number hidden in that sentence that isn't obvious. It says the driver hits the brake, stopping the car. So the car is going to stop, meaning that eventually it's not going to be moving anymore, so it's going to have no speed. Finally, it says what is the acceleration of the car when all this is done. So we have our 3 numbers, which is what we need to solve. We have a question mark, so we know what we're trying to solve for. And we have our blank spot, which is time, which means we're going to pick the kinematics equation that does not have time in it. That kinematics equation is Vf squared equals V naught squared plus 2AD. Now we have to rearrange this for acceleration. So we're going to subtract our initial velocity squared term to the other side. So I get Vf squared minus V naught squared equals 2AD. Now we have to divide out the 2 and the D. So on the left side, I will get Vf squared minus V naught squared all over 2D. And that's going to give us the acceleration. Now we just have to plug in our numbers. Final velocity was 0, so I'm not going to write down 0 squared. I'll just skip that. But we have to make sure we leave the negative. Very important. So negative. And the initial velocity was 20 meters per second. And we square it, divided by 2 times the distance, which was 50 meters. That's going to give us acceleration. 20 squared divided by 2 times 50, so that'd be 400 up top. Don't forget the negative. All over 100 gives us negative 4 meters per second squared for acceleration. And the negative is because it's slowing down, going back over to the left.